Okay, so now let's talk about autocorrelation. So this is an example of data that's autocorrelated. So here you can see that the error term, for example, the error term here at this point, can you see this? The error term at this point is positive. The error term at the next point is positive. The error term at the next point is positive. The error point at the next point. The error term at the next point is positive, and so on. So the error term is not randomly distributed here off of the regression line. The error term at one point depends on the error term at the previous point. Okay, so this is an example of what's called autocorrelation. This violates assumption, I think it was assumption 3, or that we just finished talking about. So in that case, we get various problems in our when we do regression. This is one way to express the fact that there's autocorrelation. Basically, what we can say is that what happens at time t is related to what happened at time t minus 1. And some of the consequences of autocorrelation are that you get underestimates. It underestimates the variance of the error term. It overestimates R squared. And the usual T and F tests are invalid. And there's something called the Durbin-Watson test statistic, which tests for the existence of autocorrelation. That's not a function that you can get out of Excel. You'd have to make it yourself. It's not that hard to make it, but it's not pre-built as one of Excel's functions. Some other software does have it. Okay, now there are some other ways of handling autocorrelation. So let me just talk a little bit about that. Something called autoregression. So let's just talk a little bit about that. Autoregressive models are a way to handle autocorrelated data, like time series data is often autocorrelated, like we just saw. The time series, actually, I forgot to mention it. We didn't look at it carefully. What was that over here? This was, by the way, this was stock price over time, right? So as the stock price one day is related to the stock price the next day, right? If the stock is sort of above the expected value, which is represented by the regression line, if it's above the regression line one day, then it's probably going to be above the regression line the next day. That's the idea. Okay? Now let me go back to that other one. So one way of handling that is autoregressive models. Frequently we find that the values of a series of financial data at particular points in time are highly correlated with the value which precede and succeed them. And so we use what's called a lagged variable as part of the modeling procedure. The creation of an autoregressive model generates a new predictor variable by using the y variable lagged one or more periods. So here's the model that they're talking about. So y at time t, y sub t, is a function of y sub t minus 1. and maybe y sub t minus 2, and so on. And then error term, e sub t, epsilon sub t. The dependent variable is a function of itself at the previous moment of time, or previous period. The most often seen form of the equation is linear form. Now this previous one that we just saw here doesn't specify, we write y as a function of y sub t minus 1, but what kind of function of y sub t minus 1? Is it y sub t minus 1 squared? Is it y sub t minus 1 cubed? We're not specifying yet. But they say the most often seen form of the equation is in linear form. It doesn't exactly look like linear, but that is linear, right? Because it's just sigma, means just adding the y sub t minus 1 or y sub t minus 2 or however far back you're going to go, but you're only adding. So that's actually linear. And now, how far are we going to go back? We can, the sigma says go from 1 to p. So if we just went from 1 to 1, that would mean just y sub t minus 1. If we went from I equals 1 to 2, p equals 2, then we'd include t minus 1 and t minus 2. So p is called the autoregression rank down at the bottom there. Let's ignore this. So a first order autoregressive model is concerned with only the correlation between consecutive values in a series. So just looking at what happened one period back. So it's just like that with just t minus 1 only. A second order autoregressive model considers the effects of relationship between consecutive values in a series, so just one period back, as well as the correlation between values 2 periods apart. So it looks like that, right? Okay, I think that's all. The selection of an appropriate autoregressive model is not an easy task. So should you include 1 period back, 2 periods back, 3 periods back, 100 periods back? And what should be the form? Should it be cubes or squares or combinations? All of that. No easy task to do that. Once a model is selected and OLS method is used to obtain estimates, OLS means ordinary least squares, or just the least squares method that we've been talking about, is used to obtain estimates of the parameters. That's what we talked about earlier. The next step would be to eliminate those parameters which do not contribute significantly. Well, we won't do that. Okay, we won't do that. Okay, that's all.